Good morning, good afternoon, or good evening, depending upon where you live around the world. Yes, I know, I'm back at it again, looking at the different interfaces for the hubs or hubless type ideas for building my dome. I've made 2 videos, quite extensive ones, which I've deleted. How else do you waste a Sunday morning than making something that gets away on you and you then consider it not ideal, I'll say. So I'm going to condense the video and just go over it briefly and say the different points that I've considered. This was the my apologies for that zoom. I'm having a bit of problems here. I have to get a 3D mouse, won't I? This is a consideration, one where the threaded rods are, don't worry about the length, they'll be a lot longer than this, but one where the threaded rods themselves are inserted into the end grain of the timber, and an interface is required to allow the nut washer to bed correctly so that as not to stress either the nut or the thread, and it needs to be at 90 degrees. So came up with something that I think is viable, one that I'd use in my final conclusion to this, but this was the orientation that I had some concern about, because the threaded rod would have to be embedded so deeply to dissipate the energy, to stop the threads stripping out the fibres of the timber. Still have that consideration for this approach. I think that the length of thread would be sufficient to resist that. I have come to the conclusion through non-engineering processes, but I think that the bottom rod or threaded rod is the one that would see the most stress, the way the loads would be imposed upon this structure, and therefore this is the one that we've got to consider the most, and the upper one can be perhaps considered equal or lesser than as far as stress loads and then requirements put upon it. Therefore a threaded rod which has only the engineering type thread to embed itself in the end grain of the timber can be replaced by an engineering or a high quality timber screw which has its threads designed to bite into timber. But again, we're biting into end grain, even with those like the specs type screws where they've got really good designed thread, it's cross grain, and you've always got, I don't know, I haven't asked specs company, but though I'm sure would say the same thing here, well their screws are good but it is end grain, you have to have long ones, sir. Yay. Then I considered some other options. Getting away with having to cut the strut at a specific angle, well that would be easier to do, but the interface that I came up with in this situation required them to be built very accurately to give the angle of the strut as on an individual basis, depending on where they're positioned around the hub. And I thought, yeah, that could be a bit of a pain in the neck, so not so good. Plus, in my version, I needed double up on the angle, or these circular, semicircular interface pieces. Then I had a look at this. This is where the bolts are actually straight through on a plate. You have to make up a bracket. Came to the conclusion, too much manufacturing, too much issue. Then I went to a 6 inch deep or 150 millimeter deep timber. That's actually a good consideration. And then with that change in thinking, I reintroduced that idea I was covering previously about having the bolt on the bottom, the one that was doing the most work, inserted in a screw long screw, a 150, 200 millimeter screw, like a Spax screw or equivalent brand, bite into the timber on the top because of the type of thread. But as you note, I've angled the threaded rod to be 90 degrees to the cut angle of the strut, meaning I can embed that at a specific point, easily obtained through SketchUp drawings, embedded at 90 degrees and threaded into the timber slightly across the grain, getting away from splitting issues and mitigating the stripping issues of end grain. Still end grain, but it's less end grain than the other end grain. Okay, I'll leave that one alone, because I thought to myself, why not do this? I had considered a square or rectangular plate put in. It's got a thread on it. In this case, it's 30 by 6 mil, or it could be any thickness. But because that would have to be at 90 degrees to the thread, and that meant, each strut is different, and will I get that slot accurate? I rejected that idea pretty quickly. Went back to this, which is a steel dowel, hole through the middle, threaded. That gives a lot of thread surface for the threaded rod to be slipped into a hole. This time the threaded rod is not engaging the fibers of the timber, it is engaging steel. Therefore I can, and ignore this extra bit out here, that was just from a previous drawing, but now I can stress this, or load up this threaded rod to a high degree, in a good sense, an engineering sense, to hold the hub together with the strut. And I'll make a bold statement, I could almost get away with thinking of this as being 100% of the strength for the connection. It's not, but you could say then, okay, if you think it's 100%, by putting this large screw in, David, you have now effectively gone 120 or 130% of what this hub could achieve. So I've actually exceeded. That's wrong, but it's not a bad way of thinking for a builder. An engineer would probably slap me around the ears a few times, but I could get away with a high loading of this, which would hold the geodesic dome together pretty darn well, and then putting this in as additional strength and insurance. Remembering, wind loads and snow loads, imposed loads of whatever, on the outside would have this fixing acting for the majority of that load. However, if you get wind going across a surface and creating negative pressure, and therefore effectively positive pressure underneath, it's this one that would need to resist that condition and therefore pressures. So this is not to be ignored. I do not want my dome falling apart, as I've seen others fall apart. So, and they do, and they can, and they will over time if this issue is neglected or under-engineered. Am I over-engineering it? Don't know, I'm not an engineer. Am I overbuilding it? Yeah, probably. So all we do here is neutral axis of the timber, ideally, or as close as we can get to the neutral axis. Drill a hole in the strut, which is a little bit of an issue itself the deeper you go, but this isn't too deep, so it shouldn't be too much of a problem. So hole through here to the neutral axis. You've seen these wee assembly components for furniture, and they've got this wee steel dowel, probably an 8mm or 10mm dowel, and they've got a little slot in the end of it so you can get your screwdriver in just to turn it, so it allows you to line it properly before when you're threading in your particular threaded rod or bolt. So this is just a big brother version of it, and I can put my nut. I still need I haven't drawn it here. I still need an interface here for my nut, but I've got a wee bit of a thought in the back of my mind I might try and chase down the idea for, make it easier. But that means I can do this assembly way easier, far stronger, with more quantifiable pressures engineering wise, and anything that's easy is less likely to cause you grief later on, and it'd be cheaper. Additionally, there is the option of having the hubs split in half, so that you could effectively think of the two fixing methods as independent. They may well work, well, they will work in concert with each other, but they can be independent. And I saw that in another drawing of a particular type of dome assembly, and I thought, oh, that's not a bad idea. That means I can, let's think it. I was thinking of having a slot here so that when I assemble the dome, I can slot the hub over the head of the bolt or the nut, nib them up lightly, and assemble the dome, and then once everything's in place, nib up those bolts and then insert the screws. Now, without having to put a slot in it, if I had two rings that were working independently of but in concert with each other, I don't need to slot this hole any longer. I can insert this ring, this half ring, onto this particular fixing, and once that's been in place, I can then position my next ring on top and then screw through that. Is that as strong as this? Well, if they're working in concert with each other, I'm going to say there's not, oh god, here again, engineers will be running at me to slap me, but I'm going to suggest that there's not much of a downside by having a two-piece hub. The version I saw actually had a plate top and bottom where they put a bolt through it to hold it together, and that may well be a requirement. But because I was thinking that this is working independently of each other, I may get away with it. It's a guess. I'm throwing it out there, but that'll be for another video. I'll actually cover that. So, waffling on a little bit, but I just wanted to cover the ideas because as I am talking, they're coming to the surface for me to put in the video, so they're not well thought out. Pausing for dramatic effect. I think I like that idea actually. That whole, I'm going to have to do another video. I've got another one that will talk about the hubless design. So that's still, it's still probably got prominence in my consideration for the dome I build. But sometimes you really want to do something that's a little bit more different. And I think this is quite elegant. The way it's going to look good. Do I do it for that reason only? No, but I'm going to have to make some models. After all, I've got timber that I can actually use. It's not treated to the degree I need it treated, but I can use models to make a determination of what looks good and what works well, and one will take precedence over the other once I've made them. I'm going to leave this video alone now, and I'll wander off and I'll make the next one, and we'll talk more specifically about some of the things that I haven't shown here but have mentioned. So with that, goodbye, and I'll see you in the next one. Okay, see you later.